So imagine an AI built to identify specific objects in photographs.
Okay.
In the lab, it scores a perfect 100%. But then the moment it gets deployed in the real world, it completely fails.
Oh, wow. Yeah.
Right. And when developers look under the hood, they realize the AI wasn't identifying the object at all. It had basically learned to recognize the specific background lighting of the lab where the photos were taken.
That is such a classic issue. Yeah.
Exactly. So the AI was functioning perfectly, but the underlying data it was fed was fundamentally flawed. So welcome to another deep dive. Today we are looking past the algorithms to examine the actual, invisible engine of modern tech, which is the discipline of data science.
Yeah, and that lab example, it really perfectly captures our mission today because we are going to unpack how data science physically acts as the refinery that, well, transforms raw data into the necessary foundation for modern AI.
Right. Because right now I feel like people treat data science and AI as just, interchangeable buzzwords.
Oh, absolutely, they do. But without the rigorous mathematical structuring of information beforehand, any artificial intelligence built on top of it is essentially flying blind.
Which is terrifying when you think about it.
Yeah.
And the scale of that raw information is what I find so staggering. I mean, we're not just talking about neat little spreadsheets with columns and rows here.
No, not at all.
Our sources emphasize unstructured data. So like millions of video files, erratic readings from factory sensors, massive blocks of just unstructured text.
Right, and processing that unstructured chaos is really where the actual mechanics of data science come into play. Because you can't just feed raw sensor logs or, say, a million customer service transcripts into an algorithm and expect a coherent result.
Yeah, it would just be garbage in, garbage out.
Exactly. So data science mathematically scrubs that information. Like if we take those transcripts, a data scientist converts the text into vector embedding.
Extra embeddings, okay.
Right. Which is essentially turning messy human language into coordinates on a multidimensional graph based on context. So they are mathematically calculating the distance between a satisfied customer and a frustrated one.
Oh, I see. So the algorithm actually has hard numbers to work with.
Precisely.
So
Yeah.
instead of the old analogy of like putting together a jigsaw puzzle, it's much closer to crude oil refinement.
Yes.
You have this massive pipeline of raw, unrefined material, say millions of raw credit card transactions,
Yeah.
and pumping crude oil straight into a car engine will just destroy it.
Right.
So data science is the refinery that distills that crude log of timestamps and merchant codes into, high-octane insights, like pinpointing a sudden shift in regional consumer spending.
That's a great way to look at it. And that refinement process is critical, particularly when we reach a stage called feature engineering.
Okay, what's that?
Well, think of this as choosing the load-bearing pillars for your analysis. So if you're trying to predict housing prices, feature engineering means taking a raw data set and actively calculating something new, like price per square foot.
Oh, right.
And then feeding that specific metric to the algorithm, you are isolating the signals that actually matter, making sure the system focuses on the right variables instead of just, background noise.
Wait, let me push back on that for a second.
Sure.
Because if isolating those signals and finding patterns is what data science does, where is the actual boundary line between data science, machine learning, and AI?
It's a good question.
Because if machine learning is finding patterns and AI is acting on them, aren't those practically the same algorithmic process, just, plugged into different outputs?
It's a subtle but really vital boundary. Think of it as a sequence of escalating questions. So data science asks, what does the historical data tell us? It sets the table. Then machine learning is the specific mechanism that asks, can a mathematical model learn to predict future patterns from this structured data? So it's the learning engine.
Got it. So it learns from the table we just set.
Right. And then AI is the broader application asking, can we build a fully autonomous system to perform a complex task using those predictions? So machine learning is just one tool in the AI toolkit.
Oh, I see.
You can have an AI system based on hard-coded rules, but the ones dominating our world today rely entirely on that machine learning engine, which in turn relies entirely on refined data.
Which means they are a strict sequential pipeline. Any statistical flaw, unrepresentative sample, or even just a missed signal at the starting line completely derails the final product.
Oh, 100%. The structural integrity of the data dictates everything. You can deploy the most technically sophisticated neural network on the planet, but if your training data is skewed or incomplete.
Like the lighting in the lab example from earlier.
Exactly. The system will fail in catastrophic ways. Quality control in those early data science stages isn't just best practice, it is the structural foundation of the entire system.
But getting that data mathematically clean is only half the story, right?
Right?
Because once it's structured, we're seeing this massive continuous feedback loop between the two fields. Data science enables AI, but the tools we are building are now aggressively accelerating the underlying science itself.
Yeah, it's fascinating. We are seeing automated machine learning models dramatically speed up the very data preparation and feature engineering processes we literally just discussed.
Wow.
And generative models are being used to synthesize missing data sets or explore complex matrices for hidden correlations that, honestly, a human data scientist might just miss.
So the refinement process gets faster.
Yes, the AI gets sharper, and then that sharper AI builds better refinement tools.
It's like an engine that constantly upgrades its own fuel efficiency. And that compounding effect is altering everything from, predicting supply chain bottlenecks to executing high-frequency trades in milliseconds.
Right.
But it all comes back to the structural integrity of the raw material.
It really does. Data is the raw material, data science is the refinery, and AI is the autonomous engine acting on that refined fuel. The future of this technology isn't just about building larger engines. It requires intense human oversight to ensure the fuel we are pumping into them is pristine, accurate, and structurally sound.
So what does this actually mean for us as we navigate a world increasingly run by these automated engines? If an AI's intelligence is completely reliant on the unglamorous underlying scientific discipline of its data, how many of the automated systems deciding our loan approvals, our medical triage, or even our route to work are quietly running on statistically flawed, unrepresentative data? And honestly, how would we even know until the engine seizes up?